Welcome to a new episode of Science. Today we will talk about elements. So let's start. What is matter? The toy models in the photograph that you can see stand for different things. If you took the models apart, though, you would get the same basic building units. Yes, for sure. If you mix the blocks together, you cannot tell which model a block came from. In a similar way, all matter is made of the same set of building blocks, which are the chemical elements. An element is, this is the definition of an element. An element is a material that cannot be broken down into anything simpler by chemical reactions. So an element is a material that cannot be broken down into anything simpler by chemical reactions. The ancient Greek philosopher Aristotle believed that all matter is made of four elements, which are earth, air, water, and fire. Aristotle's elements are not true elements, yes, because fire is not matter, and the air and earth are made of many different materials, not just one. Water can be broken down into hydrogen and oxygen. The hydrogen and the oxygen cannot be broken down into simpler substances, so hydrogen and oxygen are elements. Today, scientists know of just over of 112 elements with different properties. Three important properties of elements are number one, the state of matter at room temperature for each one of them. Number two, the way these elements combine with other elements. And the last one, whether elements are metals, non-metals, or metalloids. Okay, most elements are solid at the room temperature, some are gases, and a few are liquids. So keep this in your mind. Most elements are solid at room temperature, some are gases, while a few are liquid at room temperature. Some elements are more likely to combine with other elements to form new substances. These elements are more chemically reactive. The elements that tend to combine with other elements, they are more chemically reactive. For example, as you can see, magnesium is very reactive and is used in fireworks, as you can see. Okay, metals. What about metals? These are elements that share common properties, such as shiny luster, have a shiny and outer covering, which is shiny. Also, it is a good conductor of heat and electricity, conductivity, and flexibility. It can be shaped. Yes, sodium, copper, and gold are examples of metals. Sodium, copper, and gold are examples of metals. What about nonmetals? Nonmetals are elements that are poor conductors of heat and electricity. They are dull, they are pale or faint, and brittle. They are fragile like chlorine and oxygen. These are nonmetals, like the ones in the picture, the carbon, sulfur, and also the phosphorus. What about metalloids? These are elements in between. Some elements, such as silicon, have properties between metals and nonmetals. That's why they are called metalloids. Then smaller and smaller. If you cut a piece of an element in half, will it be still the same element? Yes, the two halves have the same properties as the original element. What if you kept cutting it in half again and again? Eventually, you would have the smallest piece of element possible. Yes, like this one. If you keep cutting a piece of aluminum in half, you would find that it is made of atoms. So in 1803, John Dalton, who is a scientist, proposed that elements are made of tiny particles. Dalton believed that these particles could not be cut into smaller pieces. Today, we know that Dalton's particles, they do exist and we call them atoms. So what is atom? An atom is the smallest unit of an element that retains the properties of an element. So an atom is the smallest unit of an element that retains the properties of an element. Retains means keeps or stores the same properties of the element. Atoms are made of even smaller particles, but these particles are not elements. They are the same for every type of atom. The nucleus of the atom is the center of the atom, and the nucleus is made of protons and neutrons. So what are protons and neutrons? The proton is a particle with 1 unit of positive electric charge. The number of protons in an atom is called the atomic number, and it determines which element it is. So we depend on the number of protons or the atomic number to know the type of the element. And the neutrons, a neutron is a particle with no electric charge. It is neutral. Atoms also contain electrons. An electron is a smaller particle with 1 unit of negative charge. So electrons have negative charge. Electrons move within the space outside the nucleus. So now, most of an atom is the empty space. Most of an atom is empty space. Keep this in your mind. Usually the number of electrons and the protons are equal. Keep in your mind that the protons are inside the nucleus while electrons are moving around the nucleus from the outside. They are equal, so the atoms have no overall charge. Protons and neutrons have about the same mass. So this mass is called the atomic mass unit, which is abbreviated as AMU, atomic mass unit. Electrons are smaller and have about 1800 times less mass than 1 AMU. Can you imagine this? If you add up the mass of all the protons and the neutrons inside the nucleus of an atom, you would get the atomic mass of the atom. Let's take an example. And for example, an oxygen atom, there are 8 protons and usually 8 neutrons. So its atomic mass would be 8 plus 8 equals 16 AMU, atomic mass unit. In 1913, Niels Bohr, another scientist, pictured an atom's electrons moving around the nucleus like planets moving around a star. But today we know that the real picture is more complex because the electrons around the nucleus act like a cloud of electric charge in many ways. As you can see from the picture, this is the picture of an atom. We have in the center, this is the nucleus, which consists of positive protons, these are the green ones, and the neutral neutrons, which are the yellow ones. Okay, then we have, can you see the electrons, the red ones with the negative charge that move around the nucleus? All this is a single atom. Okay, then let's move to molecules. When you snap toy bricks together to make something, we are back to the toy bricks. When you snap these together to make something, many parts act as one part. Yes, the same thing happens for atoms when they form molecules. Molecules are particles with more than one atom joined together. So the molecules, these are particles with more than one atom. The atoms are joined together. Most of the atoms in the world exist as a part of a molecule. Most of the atoms in the world exist as part of a molecule, not on their own. Objects in the world are just many molecules grouped together. Let's move. When a molecule forms from elements, atoms link together through their electrons. Yes, so the molecules form by joining or linking the atoms of elements through their electrons. This causes molecules to have a very different properties than the properties of the element that made the molecule. With about 112 elements, can you imagine how much chances or how many chances of building different molecules? So with about 112 elements, different kinds of molecules that can be made is nearly infinite or unlimited number of molecules. By forming molecules, atoms combine to form different materials and provide all the variety that you can see around you. Scientists describe the molecules by combining letters and numbers into a chemical formula. So the chemical formula used to describe the molecules. The letters tell which type atoms are in a molecule, and the numbers are known as subscripts. and they indicate the number of each atom. So letters and numbers, this is the chemical formula to describe the molecules. The letters to show the type of the atom, the number to show the number of atoms in each element. Okay. Like the oxygen, for example, the oxygen that we breathe is a molecule formed by two oxygen atoms, and its chemical formula O for oxygen, this is the letter, it is capital, and 2 for the number of atoms. So how are elements grouped? Let's see. Each element has a symbol, yes? The symbols for most elements are one or two letters. The first letter is always capital letter or an uppercase letter. Second, the letters are never capital. They are always lowercase letters. Keep this in your mind. This is very important. So, symbols may look like an element's English name, like C for carbon. However, many came from ancient names such as AU for gold, whose Latin name is arum. The element symbols are the same letters used in the chemical formulas. Okay, do not forget this. In 1869, Dmitry Mendeleev, a scientist, made element cards. Mendeleev ordered the elements from lightest to heaviest. Mendeleev found that the elements' properties repeat in cycles, so he made the cycles of elements into rows in a table. Mendeleev's table is called the periodic table. This is the table of elements, the periodic table, because the properties repeat in cycles or periods. Each column in this table contains elements with similar chemical properties. Like what? For example, elements in column 17 combine easily with other elements, while elements in column 18 do not react with other elements. And here is a picture of the periodic table. This is the most recent version of the periodic table. So let's talk about some elements. Like hydrogen. Hydrogen, or H for hydrogen, this is a reactive element that burns rapidly. Hydrogen, reactive element that burns rapidly. It is a gas. Hydrogen is a gas at room temperature, and hydrogen is a non-metal. While carbon, C for carbon, carbon is reactive and it can burn. Carbon is solid at room temperature, and the carbon is non-metal. This is a part of carbon or a piece of carbon. Also, we have potassium, or K. Potassium is very reactive that it starts fire in water. Can you imagine starting a fire in the middle of the water? Potassium is solid at room temperature. Potassium is a metal. It has a shiny luster, as you can see. We have also iron, Fe for iron. Did you notice the F is capital while E is small? So this is the symbol of the element iron. Iron is reactive and rusts quickly. Iron is solid at room temperature. Iron is a metal. While silicon Si. Silicon is not very reactive. Silicon is solid at room temperature. Silicon is metallite. It has some properties of metals and non-metals. So which are the most common elements? In space, the most common elements are hydrogen and helium. These two elements make up about 98% of the mass of the universe. 90% of the mass of the universe are only hydrogen and helium. But on Earth, hydrogen is common, yes, because it is found in water, while helium is found only in very small amounts. Along with hydrogen, the elements oxygen, silicon, aluminum, nitrogen, and iron and calcium are common on Earth. Heavier elements of these tend to collect in the crust, while lighter elements tend to reside in the ocean and atmosphere. Okay, so there is also a great deal of iron in the core of Earth. You know that the layers of the Earth, we have the crust, which is the outer layer, then we have the mantle. Moving forward or deeper, this is the outer core, then the inner core. So the scientists Think that the inner core is solid iron, which is covered by a layer of liquid iron surrounding it. This is the outer core. Okay, so let's see. Now we have the air, or we have the air and water and even land or crust. So in air, it is about 78% nitrogen, 21% oxygen, and we have other elements about 1%. While in the ocean, we have oxygen 85%, hydrogen 11%, and we have other elements 21%. But in the Earth's crust, we have 45% oxygen, 28% silicon, and other materials or other elements. Just like all matter, the plants and the animals also are made of elements. Much of the oxygen and the hydrogen in animals came from the water because they drink water. In fact, about 60% of animal body weight is water. This is not a strange thing. Most animal bodies are made from carbon, oxygen, hydrogen, nitrogen, phosphorus, and a small amount of chlorine and sulfur. The bones and teeth, they contain most of the calcium in the body. The plants and the animals are mainly made of carbon, hydrogen, and oxygen. As you can see, these for animals, 78% oxygen, 11% carbon, 10% hydrogen, then we have nitrogen, phosphorus, and other animals. Also, these are in plants, but in animals, we have 63% oxygen, 19% carbon, 10% hydrogen, and other elements like nitrogen, calcium, phosphorus, and other elements. Okay, then let's move to the last part, which is how do we examine elements? Atoms are incredibly small. A single hydrogen atom is only one, this is 0.000000001 meters across. So that's about 1 millionth the width of a human hair. Can you imagine a human hair? This is 1 millionth times smaller than the width of this human hair. So even large molecules are too small to be seen with an ordinary light microscope like this one. This is the simple microscope. So how can we examine elements? Special electron microscope. This is the electron microscope. Can you imagine how huge this one is? Special electron microscopes use electrons instead of light particles to examine a sample. Electron microscopes can show single atoms or the arrangement of the atoms. Okay. Then another special microscope, this one is much larger than the electron microscope. This is called the scanning tunneling microscope. Scanning tunneling microscope also shows single atoms. But the scanning tunneling microscope, how it works, it has a needle tip that moves over a surface. The needle is so sensitive that it moves up and down over each atom in the surface. The up and down motions are turned into an image, like this one. As you can see, they were examining diamonds. Diamonds are made of carbon atoms. So this is the image of the electron microscope to your upper right. An electron microscope shows the structure of carbon in a diamond. This image was made by shooting electrons on the diamond. Can you see the image? While the one to your lower left side, this is a picture of carbon atoms is from a scanning tunneling microscope. Can you see the difference between them? I hope you enjoyed this episode. See you in the next one. Thank you guys and goodbye.